So you've probably heard the term blockchain thrown around a lot. Bitcoin, NFTs. But what is it really? At its core, a blockchain is just a special type of digital ledger. Think of it like a notebook where you can write down transactions, but with a few very important rules. First, once something is written down, it can't be erased or changed. It's permanent. Second, this notebook isn't kept by one person. Copies are shared across a huge network of computers all over the world. This makes it incredibly secure because, to change something, you'd have to change it on thousands of computers at the exact same time. Practically impossible. The chain part of the name is pretty literal. Each new page, or block of transactions, is mathematically linked to the one before it, forming a chronological chain. Alright, so if blockchain is a single-lane highway, what's the alternative? Let's talk about something called a DAG, which stands for Directed Acyclic Graph. Now, that sounds super technical and complicated, but the concept is actually pretty straightforward. Forget the single-file line for a moment. Instead, imagine a family tree, but for transactions. Each new transaction links back to multiple previous transactions. It's like a child having two parents, who in turn each had two parents, and so on. It creates this branching, web-like structure instead of a straight line. The directed part of the name means the links all point in one direction from newer transactions to older ones. You can't point to something that hasn't happened yet. The acyclic part means it never loops back on itself. You can't be your own grandpa. The flow is always forward through time. This structure allows what blockchains struggle with: parallel processing. Multiple transactions can be added and confirmed at the same time. So we have the blockchain, which is super secure but can be slow, and we have the DAG, which is super fast but can have different security considerations. What if you could take the best features from both and combine them? Well, that's exactly what BlockDAG aims to do. It's a hybrid model that keeps the familiar, secure structure of blocks from a blockchain but arranges them in a DAG's web-like pattern. Instead of a single chain of blocks, you get a complex, branching structure of blocks. It's like taking the bricks of a blockchain and building with them using the blueprint of a DAG. In a BlockDAG system, when a new block of transactions is created, it doesn't have to wait to be the next one in line. Instead, it can reference and link to multiple previous blocks that don't have a successor yet, the leaves of the graph. When you put a traditional blockchain and a BlockDAG side by side, the biggest difference you'll notice is the structure. It's the single file line versus the sprawling web. A blockchain is linear and one-dimensional. One block follows another in a strict, unbreakable order. This is great for simplicity and clear consensus, but it's also the biggest weakness. Two miners find blocks at the same time. The network picks one and discards the other. That discarded block becomes an orphan. Wasted work. BlockDAG embraces simultaneous blocks. If two blocks are created at the same time, add them both. All blocks get incorporated into the graph. No work is ever wasted. That boosts efficiency and security. An attacker could build a secret chain on a linear blockchain. In BlockDAG, attacker blocks are absorbed into the wider graph. Harder to dominate the network. Structural difference. Massive impact on performance. So, why should you care about any of this? BlockDAG could solve the scalability problem that has plagued blockchains for years. Imagine a world where decentralized applications dApps are as fast and responsive as the apps on your phone. That's the promise of BlockDAG. Massive increase in transaction throughput makes global-scale blockchain services possible. Social media platforms, financial markets, all without the lag and high fees we see today. It's not just faster, it's more efficient and more democratic. Mining today is dominated by huge, centralized mining pools. Massive server farms concentrate power. BlockDAGs can incorporate blocks from smaller miners that would otherwise be orphaned. That creates a more level playing field. Of course, no technology is perfect, and BlockDAG is no exception. It comes with its own set of challenges that researchers and developers are actively working to solve. One of the biggest hurdles is complexity. A simple linear chain is easy for everyone on the network to agree upon. But a multidimensional graph of blocks makes ordering transactions much harder. Developing consensus algorithms that are both fair and efficient for this structure is a major technical challenge. It's one thing to build a multi-lane highway, it's another to design the traffic control system to prevent chaos. BlockDAGs are built to process huge numbers of transactions, so the ledger can grow very large, very fast. That growth could make it hard for regular people to run a full node on a personal computer. That risk could lead to centralization, where only big servers can participate fully. Researchers are exploring data pruning and other ways to manage ledger size without sacrificing security. The tech is still new and relatively untested compared to decade-old blockchains. BlockDAGs look promising in tests, but they haven't been battle-hardened like Bitcoin or Ethereum. There could be unforeseen vulnerabilities or economic incentives that behave differently at scale. So, wrapping this all up, what's the big picture? BlockDAG represents a really exciting evolution in distributed ledger technology. It takes the core idea of a blockchain, secure, immutable blocks, and rearranges those blocks into a flexible, high-throughput DAG structure. Think of a single-lane road. Now imagine a multi-lane superhighway. Split-screen, slow road versus bustling superhighway. This shift enables parallel processing, which means more transactions, faster confirmations, less wasted energy. It's a direct answer to the scalability bottleneck holding back adoption. The potential use cases are pretty much endless. Internet of Things, decentralized social media networks, online gaming universes with verifiable ownership of assets, supply chain management, tracking goods end-to-end. There are challenges to overcome like complexity of consensus protocols, managing the ledger size. Still, the promise of BlockDAG is too significant to ignore.